Okay, class, today we are on 8M2, lesson 10, sequences of rigid motions. And what we know so far is that the rigid motions are motions that you can apply to an object that keep it the same size. It keeps the segments the same size, the line segments, the angles inside the segment the same size. And there's three basic motions that we've learned about that are rigid motions. One is called translation. You take an object and you slide it along a vector. You take it and you slide it along a vector. It maintains the same orientation. Okay, let's use this. We have our rectangle and we can move it to the left. We can move it to the right, but notice the top is still the top, the left is still, or whatever side this is to you, the right, the bottom is still the bottom. The second thing that you can do that keeps it the same side, right? Whenever I move it, this is still the same length, this is the same angle, this is the same length. The second thing you can do is you can rotate, right? If I rotate an object, I can rotate it 90 degrees, 180 degrees, 270, 360. 360 is all the way back around, right? Oh, my glasses got small. Whoa, now they're big. Whoa, that's kind of cool. All right, now the last thing that you can do is you can rotate, you can reflect it. And reflecting is just reflecting it about a line. So notice, it's basically just turning the thing upside down. So if you have it right side up, now upside down, and notice that all of the lengths are still the same. You still have two long sides, two short sides, all the same angles. So that's the whole idea. Let's see, where are we? This is my lesson, my little lesson review pad that I build for myself every day. Okay, so what we're going to do today is we're going to review a few of the examples from today's lesson, lesson 10. So we're going to do examples 1, 2, 3, just kind of go over what you went over in class, but kind of do it kind of quick and maybe give you a few hints about it. The second thing we're going to do is we're going to do an example. We're going to go back to GeoGebra, that tool that we've been using that shows you that can kind of do quick rotations, reflections, and translations. I'll give you a problem in that world, asking you to determine whether or not you think something has been was changed using a series of reflections, translations, and rotations, which would mean rigid motions. Was it moved using a system of rigid motions? And then the third thing would be, I'm going to start to give you two pieces of homework help, where I will show you an example that kind of helps you through the homework with saying, hey, let's move this thing in certain ways and do certain things to it. And maybe those explanations are not that clear, so I'm going to show you that, an example that's like the homework, and then I will show you, well, kind of two of those. All right, so let's get going. I know it's a lot of overview. Let's get to the meat of the lesson. Okay, so here we are, and we're looking at three of the problems, right? Three of the problems from the lesson today. And I want to give you a kind of a tip. So remember, these things are all, you got to determine whether you think these are all changed via a series of rigid motions. And there's going to be two things that we need to think about, right? These are the rigid motions. And these are, one, translation. That's kind of like sliding and leaving the top, the bottom, the left, and the right, the right. Rotation. That's like spinning an object. And then reflection, that's flipping an object. And generally, you'll only reflect once. So that's the first thing to think about. These are our tool set of rigid motions. The second thing to think about is, are the objects the same size and shape? Size and shape. If the answer to this question, are the objects the same size and shape, if the answer is yes, then rigid motions was used. A rigid motions. That means one or more. And then B, if the answer is no, then something else was done. In other words, i.e., in other words, you cannot use these three actions to turn object one actions to turn object one into object two. Right? So that's the second thing. Okay, so let's look at this. So the first thing is can you look at, object one is this object. Can you look at object one and look at object two? And is the question, first of all, are they the same shape and size? Right? And the answer is, think about it, and the answer is yes. Because this side is the same length as this side, and this side, AC, is the same length as this side, AC. And then, this side is the same thing as this side. And notice all the angles are the same, and they're telling you, because this symbol of one line going like this says that this angle is the same. And the fact that these are both double-lined, a double-lined angle and another double-lined angle have to be the same. That's what that drawing means. So the answer is yes, these are the same. And because they're the same, that means I can use rigid motion. Rigid motions will convert one to the other. And you'll see the same thing on 2 and 3, right? This angle, these two angles are the same. It's telling you that, and these two angles are the same. So if in two triangles, two of the angles match up and the other two angles match up, then the third ones by definition have to match up. They're trying to be a little sneaky here. They could have drawn their three lines like this to tell you that angle A and A prime are the same. Same thing over here. These things have to be the same because the other two sets are the same. Think about it. If this one happens to be 40 degrees and this or 40, these are 40. Or wait, no, that's not right. That would be like if this is 20 and this is 20 and this is 30 and this is 30, then these two angles both have to be 130 because the angles have to add up to 180. So 20 plus 30 plus 130 equals 180. Okay? Oops. Let's not do that. Let's just undo. Get rid of kind of some of that mess. We'll get rid of that mess over here too. So we know, and then you can measure these with a ruler, and you can see that these two angles, or these two sides, are the same, and these two sides are the same, and that these two sides are the same. Same thing up here. Okay. So let's just think about this. We need to decide what we know that a set of rigid motions will transform one triangle into the other in all three cases. So let me give you another hint. Translations are kind of easy to see. That means, can I just slide something from one place to the other, and will it map? An easy translation was when I was showing you the box, when I was holding it up in front of my face and I was just moving it left and right. Those are pretty easy for your eye to spot. Let's just go to GeoGebra real quick. You can see that if I took an object like here, I'm just going to take a polygon, a triangle here, and I just if I just translate that, I can just move it like this, and it's pretty easy to see that this triangle is just translated to this triangle. It's translated to this one because they're both all, you know, G is still, the top point is still the top point, the left point is still the left point, and the right point is still the right point. Let me draw another one right on top of it so I can show you what I'm talking about a little bit better. If I'm just taking this if I'm just taking, whoops, what am I doing? Let's do this a different way. Okay, so let's just build ourselves another object that's been translated, and I'll help you see how this is translated. So if I can put this triangle on top of, gosh, how hard can they make this for me to show you just something so simple? Let's do it again. Dun, 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 dun. Okay. So this triangle is just this triangle translated. And you can see it if I just move it to the right to, up to, and over to, or just straight up to, that this triangle JKL is just GHI translated. Those are all the points moved 2 to the right. This is all the points moved 3 to the right. This would be all the points moved up 1. Again, pretty easy to see. All right, let's go back to Sketchpad. Hopefully that was useful in explanation. But sometimes reflections and rotations are harder to see. So let's start off with one key point about rotation. Here, I'm going to erase this here because I'm going to do some writing right here. Now, here's the key. I know that rotation, now watch this, reflection will always be needed when? Reflection will always be one of the 3 rigid motions I need to use. Reflection will always be needed when one object, vertices, move counterclockwise and the other moves counterclockwise. Reflection will always be needed when one object's vertices moves clockwise and the other moves counterclockwise. Now, notice in this case, in number 1, you probably figured out that you can just reflect this. You can reflect this object. If you put the mirror right here, if I put the mirror right here, you can see pretty much that that object can, that object moves straight along that line. Let me redraw this line. I want to draw it just absolutely perfect. If that was my mirror that goes from here to here, you can see that C and C sit right on the mirror, so they don't move, and B and B prime don't move because they sit right on the mirror. But A moves straight across the mirror in this direction. So ABC is a reflection of A prime, B prime, C prime. Now, one key point is you also knew that you needed a reflection because one object's vertices are read counterclockwise and one is read clockwise. Now watch this. If I go A, B, C, I'm moving in a counterclockwise look. This is read counterclockwise. Counterclockwise. Because it goes this way. Okay? Now this one moves clockwise. If I go A, B, C, this one down here I read in this direction, and this is clockwise. Again, this one up here is counterclockwise. So I know that I will need reflection. Now you can maybe see it, but let's just wait and let's look at this other case here. Number 2 and number 3 are going to help us identify this clockwise and counterclockwise trick, or help us understand why it's important. Now let's look at 2. 2, we wrote A, B. We know these are the same size and shape, so that we can use rigid motions. We know that translation probably isn't the first one we're going to want to use, because we already have this B lined up. Maybe we can just twist this guy up like this and get to our original case, our original object. But let's just look at something. Our first triangle, ABC, is read in a counterclockwise direction, and so is this one. This one, the second one, you read A, B, C like this. So this one also goes in a counterclockwise direction. So we know because they're both because they are both counterclockwise, no reflection is needed. So if you just think about what we can do is we can just rotate this object up. If we just rotate this object up, we will rotate. Think about we go about, you put a, you make this point your your rotation point, and on your transparency, this is going to be on the bottom. Let's just put this in a different color. Okay, so this object, this triangle, is on the bottom, and this triangle is on the transparency. And now what you're going to do is you're going to rotate. You're going to rotate the transparency up like this, and you're going to keep this B point steady, and then you are going to get your answer. So hopefully you're going to get this triangle will be laying straight on top of this triangle. Now let's look. 3 is a different case. Now notice in this first case, ABC, we're going to go, you read your A, B, C, this goes counter. In this case, counterclockwise. And in this case, down here you go A, B, C. Here you go clockwise. So I know I'm going to need to reflect. I know reflections in my future. Okay? So that's the clockwise trick. Now, what I'm going to do is and I know that if one thing I can actually do is I can find a cool line here, and I could actually just reflect. Watch what I do here. If I reflect across that line, I actually will have my final reflection. I will have achieved the goal, which is kind of cool. I mean, you can see this if you just fold your paper. If you drew these two things and I folded my paper across this line, my A would match up with my A. Right across that line, and my C would line up right across my line like that. But the other thing that I can do, and one of the key things to notice is there's not just one set of rigid motions that always will map one object to another if I've determined they're the same. There's actually an infinite number of rigid motions. So one thing I could do is I could actually let's rotate this guy up around point B. Let's take my transparency and rotate this up so that C is on top of C. And now I'm going to have an object, if I rotated this correctly, right? I'm going to have an object that looks something like this. You know, here's my A prime and here's my C prime. And then what I can do is I can then reflect across this line. And that line, because that problem is almost, once I've rotated, you rotate, and then B, you can reflect as you did in number one. So one possibility again was to reflect across this kind of tricky line if you saw that. But the easier thing to do is just rotate that up so that B and B prime are lined up and C and C prime are lined up, and then you can just reflect it. Again, the key is there's more than one way to skin a cat. Okay, let's move to section 2. What I want to do in section 2 is I first want to get rid of these objects that I drew earlier for you. And we want to look and say, how can I get from object, wait a minute, let's just a sec. Let's poly A prime, B prime, C prime. Let's just make this guy be a different color. Yeah. Okay. So let's look at A, B, C, and let's look at let's then take that, and I figured out how to do this thing, freehand shape, pen. So we're going to take it from this shape to this shape, and then from this shape, we're going to look at taking it to this shape. Okay, so this is step 1, and this is step 2. Now, we can know that to get on step 1, if we think about our clockwise, counterclockwise example, we can think about how to get from 1 to 2. Now, remember, we have, you know, translations, whatever. Hopefully you can read that. Rotations. Whoa, what did I do here? I got off of my freehand pen. Rotations. And then reflections. So those are the things that I can do. Now, if I go from 1 to 2, think about, remember, I'm going to tell you it's exactly one thing can get you from here to here. And remember, if this guy is, if I go A, B, C, I'm going counterclockwise, and here I'm going A prime, B prime, C prime. So remember what our rule was. Is that a translation, a rotation, or a reflection? Right, and so the answer, think about it, hopefully you remember, is going to be a reflection. Reflection, just one. So, and it's a, and if you can probably see it, it's going to be a reflection. If I want to get from A to A, I need to reflect it across a line that's halfway in between. And notice this line that's halfway in between is also would reflect C to C prime and B to B prime. So this line DE is our reflection. Now think about number 2 here. If I want to go from here to here, this is not a reflection because I'm now in a counterclockwise direction, and this one is also in a, clockwise direction, and this one is also in a clockwise direction. I know it's not, so it's not a reflection. 2 is, again, not a reflection. because both are in a clockwise direction. And it's not a translation because A is not on the top it's on the top in the green case, but not in the blackish, brownish, grayish place. So it's not a translation. It's not translated. So it must be a rotation. And if you think about it, it's a rotation around this point F. So watch how I do this. Right? This is rotation about point F. Right? And if I kept going all the way around, see, there it is, rotating around point F. Every single point. If I go from here to here, I've rotated this guy 90 degrees, C has gone 90 degrees, and A has gone 90 degrees about point F. So, and you can do that with a transparency. So if you were to draw this triangle on a transparency, or draw this triangle on your graph paper, A, B, C, and then draw on top of it, put this object ABC on a transparency, you can then turn your transparency over, flip it over, and then to map it to A prime, B prime, C prime, and then you can draw a point on your paper here at 1, 1, and then you can just make point F be your area or your point of rotation, and then you can just twist your transparency down like that. Okay, so that's problem 2. You can see how, and you know that you have to be able to get from ABC to A prime, A double prime, B double prime, C double prime, because AB is the same length as A double prime, B double prime. These are both 4 units long. A is 2 units long. These are both right angles, and that these angles are all the same size. Angle A double prime is the same as angle A prime, or A. C is the same size as C double prime. You can measure that with a protractor. And B prime and B are both right angles. So you know that there's some set of reflections and translations and rotations that can get you there. But notice there's a lot of other ways you could have done this. You could have done this with a translation. You could have translated this object first and then just rotated it and reflected it. But this is just one of them, the infinite ways that you could have gotten from, if this is number 1 to number 2 to number 3. And maybe you can try that on your own. See if try translating this first and then reflecting. See if you can translate, reflect, and rotate it in a different order and get the same answer. I bet you can do it. Okay, so now I want to undo all of this. Let's undo all of this. And we're going to start, and I'm going to give you some help that will help you with your homework. So the first thing we're going to do is we're going to take an object, and I'm going to keep it simple. Triangles are about the simplest shape that you can use. And right triangles are especially easy to use. So we have a right triangle that has one side of 2, one side of 3, and this other side B, if you use the Pythagorean theorem, is square root of 13, but you don't have to really know that to make this problem work. So we're going to, the instructions are going to say this. And this will help you on your homework, so make sure you understand. So we're going to translate along a vector, and I'm going to draw that vector for you in a second. Translate along a vector. So let's draw that. Oh, let's just go ahead and draw that vector. Okay. B, we're going to rotate 90 degrees about a point. And then C, we're going to reflect about a line. Okay, I'll show you these points here in a second. Okay, so if we translate this along a vector, there are a couple ways we've shown you how to do this. So one way you can do it is you can take that vector and you can, you can copy it. Whoops. Undo. And make all of your new points. You can put one at 2, 5. You can put one here. Okay, so let's just go ahead and do that. So that's going to be at 2, 5. Whoops. We're going to put one at 2, 2. And then we're going to put one at 4, 2. And now we're just going to draw our object. So we have now translated this object, and let's just make it a different color. Why is this so hard? Why is it so hard? Okay, there we go. We've made it different. So we've translated about a vector. Now we're going to rotate this 90 degrees about a point. And the point I'm going to choose is point H. So watch, when I rotate this thing 90 degrees about point H, it's just going to we're just going to twist this guy down. We're just going to kind of twist him down like this. And this point H isn't going to move because that's going to be our point of rotation. Okay, so let's watch how this works. So first of all, I'm going to make a slider because it's always easiest to see when we deal with sliders. So now I'm going to say we're going to rotate about a point. So we're going to rotate this object about point H, and we're going to use the slider D to define what we do. Whoops, what happened here? So we're going to, wait, let's do that again. Rotate about a point. We're going to rotate H, rotate around a point. Boom, D. Okay, oh, that's the problem. Our slider, we have to get our properties of our slider and make sure we can move that a lot. And we're going to make our increments be 5 degrees. Okay, here we go. There we go. That was our problem. So we're going to move that 90 degrees. Now notice how that's we're going to make that a different color again. Okay, so notice we're going to rotate that guy 90 degrees. And you can do that using your transparency and your paper. And remember how we do that. We learned how to do that back in lesson 2 or 3 or something. So now we've rotated it. Now we're going to reflect it. Now we want to reflect this object around a line. So let's take a line, and I'm going to draw this line for you, and we're going to make the line be, we're going to put it like this. Yeah, line. So we're going to reflect this red triangle across this line. Now notice that means each of these points is going to be mirrored across this line. So if F prime is right on the mirror, its reflected point is going to be right there on the mirror. H prime is going to be, because it's 3 off of the mirror, it's going to be 3 on the other side of the mirror. And I prime is going, it's 1, 2, 3 off the mirror. So it's also going to be 3 off the mirror. So just imagine, see if you can create in your mind what this triangle is going to look like if you're looking at the mirror image across this line. And then we're just going to go ahead and do that for you. You may have already done this because maybe you have GeoGebra pulled up yourself. Let's see, reflect about a line. Why are we not? Oh, it's because this stupid, this guy causing problems. Just a second. Let's see. Reflect about line. Reflect this object about this line. Reflect about line. Why is this not working? Okay. Reflect about line. Come on, give it to me. What if I reflected about a point? Triangle poly. Let's see, I've done something wrong here, obviously. I've obviously done something wrong, and I didn't expect to get grief from GeoGebra. When I did this exercise. Let's see, so we translated it like that. Okay, so let's try this one more time. Come on, give it to me. Reflect about line. Duh, duh. How about this one? Reflect about line. Reflect about line. Okay, let me just redraw this object and see if I can make this thing work. And if not, we'll just do it by hand. So I'm going to move this up here, and I'm going to say reflect about line. There we go. I'm not sure why it didn't work the first time, but now you can see that this guy reflected about this one. This vertice stayed exactly on the mirror. These are 3 off the mirror, but exactly on the other side, and E prime are mirrored. Okay, so that's the second key. This should help you with your homework. Hopefully you bore with me through that tough use of GeoGebra. Now let me try one last thing that I want to show you, and that's going to be an instruction that you have to understand that they're going to give you in the homework. And that instruction says, we're going to let's just take we'll do a four-sided object just for fun, because we've been doing so many 3-sided objects. Okay, now if I was to say, reflect oops, that's not a triangle, is it? It's a polygon. Polygon A, B, C, D across the line parallel to x-axis, passing through point 1, 1. So I want to reflect ABCD across a line parallel to the x-axis. So if this is our x-axis that goes, right, it goes in this direction, and I want a line parallel to it, I need a line that goes like this, and it needs to go through the point 1, 1. So how many lines go parallel to the x-axis through point E? And if you said there's only one, you are exactly right. So let's draw that line that is parallel to the x-axis going through point E. And it's line FG. So if I need to reflect ABCD across this line parallel, what I need to do is I need to make points that are exactly on the other side of this line, the same unit. So let me just make this one, put this right on that point. It's going to make this easier. So if I reflect point C, I'm going to be here. Make these green. B is 1, 2, 3. So I got to go 1, 2, 3. A is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And D is 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to draw my object, my polygon. And it's reflected about this line, right? So you can imagine if that was a mirror, that this would be perfectly reflected across it, and A, B, C, D is reflected onto J, I, H, K. And I did it wrong because H should be right. No, this is right. That's right. Sorry. Okay, good. All right, so we are done with the lesson. Hopefully this was helpful. I know I made a few mistakes using GeoGebra. I can't figure out exactly why GeoGebra wasn't behaving for me, but we are done with lesson 10. Lesson 11, we're going to be talking about congruence. And let me give you the hint right now. Congruence, everything we've been talking about is congruent. Anytime, basically the bottom line is if you can use these three rigid motions to turn one object into another object, those two objects by definition, well, not by definition, they are congruent, and we'll see why the definitions of congruence match to the definitions of the properties of rigid motions. Again, the hint is congruence means same angles, same sides, same lengths, same shape. It's just translated, rotated, or reflected. All right. Enough for today. Have a great time. Hopefully you enjoy this unit, enjoy your math, and we'll be seeing you next time.